Don't you cherish me to sleep?
Okay, this is going to be a series of video lessons where we go through the thermochemistry unit that we're doing in class to keep us updated on material that we're a little bit behind on, and also those of you who are on track so that you can study with this information. There will be homework assignments, and there are guided notes that you guys have already received that go along with these videos. If there are any questions, please bring those to class. I'm more than happy to answer those, and I'm more than happy to help you guys with your homework. Alright, so let's get started. We're going to look at very basic thermochemistry. We're going to look at energy to start off with. The first of which we're going to look at is potential energy. That's your stored energy, or what you have potential to do. So if your parents have ever said, "Oh, well, Abby, you have such great potential," what does that mean, Abby?
That I can do better.
You can do better. There are things that you can do. So you want to reach your potential. Now you guys will learn this when you guys take physics next year. When I am standing at the top of a stool, I have the highest potential energy that I can get. It means I have the potential to fall the furthest from the top of this roller coaster, this stool. The same with roller coasters. When I jump off, I no longer have that potential energy. My potential energy is now 0 because I no longer have the potential to fall to the ground. The second one of these is kinetic energy. And kinetic energy is the energy of motion. So anything that is moving has energy. Your molecules, they're moving, they're doing the molecule dance. Right? And they're moving just slightly, so they continue to have some bit of energy. The last we're looking at is thermal energy, or heat energy. And that's us looking at the energy of molecules and atoms, and how those movements translate, or how they transfer energy back and forth to each other. We want to look at heat change, or enthalpy change, delta H, the amount of heat energy released or absorbed by any given reaction or process. First, we have to look at the difference between temperature and heat. We use those words synonymously in science, which is not correct. They mean different things. Temperature, the measure of the average kinetic energy of a system. We measure that in degrees. We're looking at the average amount of movement. We have molecules that are moving quickly, molecules that are moving slowly, and so we use temperature as our average measurement of those. Heat is the total energy of the system. How much energy does a hot coffee have? That's the heat. We're going to use 2 units for measuring heat in this class. The first of which is the joule, which is a Newton meter. You don't know what a Newton is yet, but you will when you get to physics next year. But you could also say that it is 1 kilogram times meter squared divided by second squared. When we're doing our calculations, you guys are welcome to just put J, joule. The second unit we're looking at is the calorie. These are the same calories that they use when they're discussing food, and so your body eats food and it's got a certain caloric intake. Those are really just like energy points. So it's saying if you eat something with 200 calories, you have 200 energy points. You can spend that much energy. If you are somebody who does not have a high enough caloric intake, not eating enough calories, you tend to not have enough energy. If you eat too many calories, your body takes all of that and stores it in the form of fat. So, those of you who have some muffin tops, just consider that lots of potential energy. Okay, we discussed 2 different types of processes. There's exothermic processes and endothermic processes. You should have seen these both in physical science, but let's take a minute to look at these now. Step on here. So, in an exothermic process, your reaction occurs and it releases heat energy. It will feel warm to you. But you have to get over something called the activation energy barrier. I have a candle here. Candles, they light, they give off heat. This is an exothermic reaction, but this candle will not spontaneously combust. I am not Harry Potter. I cannot wave my hand and have the candle light. So this candle sits here until we do something to put energy into it. Abby, what do?
We light it.
We light it. We push energy into it by lighting the candle, and it takes us over what's called the activation energy barrier. The activation energy barrier keeps reactions from just going. That's the reason why your candle can sit there solid and not go up in flames. Our second process an endothermic process. In this case, again, we're pushing energy into our system to get over the activation energy barrier, but we're putting more energy in than our products will give back. So our products end up having more energy than our reactants did. An endothermic reaction will feel cold to you. And it's not that it is emitting cold, it is that it is removing heat. So it's pulling heat out of the system, thus feeling cold. Alright, the last thing I want us to look at in this video is the phase changes of water. And it's going to stay the same for the phase changes of other materials as well. Temperature remains constant as you change from one phase to another. So as you heat water up from ice, when you have ice water, it should be at 0 degrees Celsius. Now granted, your thermometer might say something close to it, but it should be at 0 degrees Celsius until all the ice has melted. And the reason why is because the energy that we put into the system, or the universe puts into the system, is going towards melting the ice and not increasing the temperature of the water. Once the water temperature has increased, or once all the ice is melted, then the water temperature can increase until we get to the point where we start boiling water. Again, when we go to that phase change, your energy goes into changing from one phase to another as opposed to continuing to heat whatever material it is you're working with. And then, of course, steam goes up until eternity. That's it for video 1. If there are any questions, please let me know. I'm more than happy to answer them for you. Thanks.
Don't you cherish me to sleep? Never keep your
Alex said there's a bunch of fights at the picnic.
See his face?
Yeah, surprise
Surprise
face.
face.